Now we'll continue where we left off before with the one-way analysis. But before I go on, remember we have one discrete variable and one continuous variable. And we can do this, and that'll give us a histogram for each category, but that's not necessarily detailed enough for the information we're going to want to get from histograms. So what can we do? Well, let's close this. Now remember, if you go to Analyze again and Distribution, suppose we have, again, a variable in y, and we'll just do by. Just pick this, by, and click OK. That makes us a whole bunch of histograms. So we'll stack, and then also remember uniform scaling. That makes sure everything is on the same scale, which is important if you want to compare the histograms to each other. So you just have to do it for each of them. I think there might be a way to do it for all of them, but so this separates them like that. And just do it for a few. And we can look at each one of them this way. We can also take this, again, red triangle. Remember, the red triangle is absolutely your friend. And we can plot a few other things. We can do this. This changes the axis to a count. Or we can change the axis to probability if we want to make it probability. Do frequency. Relative frequency, rather. We can do some other stuff. So we can do show percents. That shows the percent in each bin. We can show counts. That would show the counts in each bin. If we click on here, it shows us the rows where that data comes from. And we can also, if we click here, we can move this around. And here we can change the increments, and how many, with the bin spacing for our histogram, just play around with that. If you want, you can also, I think, do that here on histogram options, that you can set bin width if you want. And we can also, so let's do that down here. We can do continuous fit and normal. Notice that that gives us actually a 95% confidence interval too, and it tries to fit a normal curve to our data. And see, this is your standard error of the mean. This is about this guy minus 2 standard errors. This guy is about this guy plus 2 standard errors. And we can also do confidence intervals for any value that we want. I do 99 there. We can even do confidence interval and other, just put in any value we want. And if we know the sigma, so say we want to use a z-test, not a t-test. Remember, when we're doing t confidence intervals or t-tests, we're using the estimated standard deviation and not the known one. Cancel, don't want to do that. And we can also do a test mean, right? So this is the hypothesized mean. And then if we want to do a z-test rather than a t-test, we just enter it down here. So we can specify hypothesized mean. Let's just make up a number 150, and then I'll just leave this blank. And then it gives us a test mean, the estimate, degrees of freedom, standard deviation, and it gives us our t-statistic. And here, so this is probability greater than the absolute value t. And if you put the mouse over it, actually pops up with a little explanation. Because so this is the two-sided test. This is a one-sided test for greater than this value, and this is a one-sided test for less than this value, and it gives you a nice explanation. And see, it actually says, it describes what a p-value is and everything, and you can do that for anything. Just do test, say maybe we know it, yeah, 27, I don't know, just make up a number. Yeah, and let's make up one that's really low, so we'll do that. Then we go down here, and this did a z-test, and it said when the asterisk means it's significant. And I think the more asterisks that are there, the more significant, it'll tell you that it is. Yeah, so that's a way you can do a test in Jump, and you could always do it on your own too, but this is how to do it in Jump. And there's really no options for these. You can just remove them. Or, yeah, very good.